This is 6.4, Transformations of Exponential and Logarithmic Functions, Video 1. The essential question, how can you transform the graphs of exponential and logarithmic functions? So in this video, we're going to start with the exponential functions, okay? So core concept here, well, nope, that's not core concept. Here you go. All right, so our exponential functions. We have horizontal translations, which means our graphs shift from left to right. Now, remember, exponential functions, whoops, look like this. Okay, remember, they don't cross that asymptote. Okay, so if they move left or right, so this curve would either move over here or move over here, that is that horizontal translation. The asymptote itself will move up or down if there's a plus number at the end. Left and right, it's up in the power, in the exponent with x, but we do the opposite of what it says because it's grouped up there with x, okay? With the vertical moving up and down, it is what it says, so if it's plus, it goes up, if it's minus, it goes down. We do not do reflection in the y-axis, but if my function is negative, it will flip upside down, okay? So instead of being up like this, it'll come down like this, okay? Now, a vertical stretch or shrink, if it's got a multiplier out front. If it's greater than 1, it's a stretch. If it's between 0 and 1, it is a shrink. Just like all the rules we've had so far for all of our transformations. So, we are going to describe our transformations and then graph them. Okay, so in number 1, our original function was 1/2 to the x power, and now we have 1/2 to the x power minus 4. So I want to state what that minus 4 does. Since it's just tacked onto the equation, that is going to move us down 4. Okay, so what that does is moves our asymptote, instead of being at the x-axis, is going to move down 4. So it moves down there. Okay? And then nothing else about our graph changed. So if you want, you can plug either equation into your calculator to get the graph, or to get points. Just remember that if you plug this one in, you need to pretend this is 0, 0, and start from there. But since you do know this other equation, you can just, whoops, that has a bad glare. Let's put it over here. We can type it in the g of x here. So we want 1/2 to the x power minus 4. And I'm going to get a table, so I'm going to push second graph, and it gives me my table. Okay, and I'm going to scroll so I can see some points, like -4, 12 is off the graph, but -3, 4 is on the graph. -2, 0, -1, -2, 0, -3, and then 1, -3.5, and then we see it just gets closer and closer to that -4, which is where our asymptote is. Okay, so if I plot these points, -3, 4, -2, 0, -1, -2, 0, -3, and 1, -3.5. We can see our curve is going like this. And remember, it approaches that asymptote but never crosses it. Okay? So that's my new graph. If it wants me to graph the original, these points would be the same, they would just be up here. So we would have our asymptote through here for the original. And then, let's see, here, here, and up there. So it's going to look like this. Okay, so that was f of x. G of x was in blue. So I'm going to label them. Okay? So let's try number 2. This time what I'm going to do is I'm just going to graph the original, and then we'll graph that one based on what happens, okay? So we need to state, first off, what is going to happen if f of x is where we're starting, and then we do these things. So it's got this plus 3 and a plus 2. That plus 3 is grouped with x, therefore we do the opposite. If it's grouped with x, it moves us left and right. And since it says plus 3, we actually go where x goes minus 3, which is to the left. So we're going to go left 3. This plus 2 on the end moves us up 2. Okay, I'm going to start by graphing the parent function. Okay, remember it has an asymptote along that x-axis, so I don't want to cross that. And I'm going to get some points. Okay, you can get your points by just plugging in 0 and 1 and 2 into that power and just plugging in numbers. The fastest way I find, though, is to get it in my calculator and getting the table. And then I'm not having to plug everything in. Now, you can see all of these ones as x gets closer to negative infinity, it's getting closer and closer to 0. So I'm going to go and I see that at 0 I have 1. At 1 I have 2.7, and it keeps going. That is that point e, or that number e. And then at 2 I'm at 7.4. So if I plot these points, and I graph. So it starts and then it grows. This one's growth. The last one was decay. Okay, so if I just kind of mark what this other graph is doing, let me see if I can find I'll use a pencil on this one. Okay, we said we go left 3, up 2. So instead of being at 0, 0, when I started plotting these points, if I go left 3, 1, 2, 3, and up 2, if I say this is 0, 0, I'm just kind of marking that here. That means my asymptote moved up 2 places. Okay? And if I say that's 0, 0, and I go from the 0, 0, I go up 1 and put a point. From 0, 0, I go right 1 up 2.5. Or I'm sorry, 2.7. And I go right 2 up 7.4. 1, 2, 3, 4, 5, 6. 7.4 is a little bit off the graph, but that's okay. So from this asymptote, I'm going to then grow. Okay, so I've showed you now 2 ways to do it. You can get your points here, but no matter what, you have to plot in these graphs. It wants that starting function, so it wants f of x. Okay, and so if you want to just find f of x first, which is easier, and then you know your shifts, and you can move your origin to whatever this is telling you, and just plot the same points from there. So that would be the second way to do it. Alright, let's do number 3. Okay, so this one starts with f of x being 2 to the x power. So let's graph that. Okay, we have an asymptote. I have my x and y values here. Okay, if I plug in 0 for x, 2 to the 0 power is 1. If I plug in 1 to x, I get 2 to the first power is 2. If I plug in 2 to x, 2 squared is 4. 2 to the third power is 8. Okay, so you do not have to use your calculator for these. You can just plug in these x values and get the y values. So if I plot these, let's see, I get this. So it's growth because that base is bigger than 1. Okay, so this was f of x. And now if I want g of x, let's state what happens. So it has a minus 3 grouped with x, and so that means it's moving left or right along the axis. We do the opposite thing. So instead of going where x is minus 3, we actually go plus 3. So I'm going to go right from the origin 3. And then it has a plus 1 on the end, and that moves us up and down. So from the origin, that's going to move us up. Okay, So those are the transformations, and like I said in the last problem, since we already found these points to plot f of x, let's just go from the origin, right 3, up 1. And I didn't write that number. Okay? And I'm throwing that in pencil because that is not a point on my actual graph. That's just me putting a point where my origin moved, which means if that's where the origin moved to, my asymptote has to move up that 1. So I won't cross this new dashed line, and I plot those points from here. Sorry, 1, 2, 1, 2, 3, 4, and that one's going to be off. Okay, so here we go. And so this is, whoops, g of x. I just started writing f of x. All right, so now I want you to go to the practice and do problems number 7, 12, 15, 18, 19, 23, and 25.